All right, final video. And this will go through 8 through 11 and then the bonus. Given triangle ABC with the measure of B, angle B, 62, and side AC extended to D as shown below, what value of X makes AB, side AB congruent to side AC? So which value would make these two sides congruent? And if that's the case, then these two angles are going to be congruent. So what value of X would make these two angles congruent? The first thing I'm going to do is take my triangle sum theorem, subtract 62 from 180, right? My triangle sum theorem tells us that we're starting off with, right, every triangle measures 180 degrees when you add up their interior angles. I'm already given 62. So, excuse me, I get 118 minus, right? So 180 minus 62 is 118. Why am I doing that? Because I want to figure out what is the measure of my missing angles. And because I know that they're going to be the same measure, I'm going to take 118 and divide it in two equal parts. So then I end up with 59. That means that angle A is 59 degrees and angle C is 59 degrees. Okay, so the only value here that would make this a 59-degree angle is the one that's supplementary to 59. And so let's take 180 minus 59. And we get 121. So if X is equal to 121, that would make that 59, making this 59. And so our answer would be D. Okay, many people selected 59 because they didn't really understand the question. Some of us chose 118 for that same reason. All right, number 9. In the measure in triangle ABC, the measure of A is 3x, the measure of B, angle B, is 4x minus 19, and the measure of angle C is equal to 3x minus 1. What statement is true? So the first thing I'm going to do here is draw a triangle because I need to see the visual of this. Okay, so I'm going to call this triangle A, B, C. And A is 3x, B is 4x minus 19, and C is 3x minus 1. I am going to use triangle sum theorem to figure out the measure of all of the sides. So I'm going to take 3x plus 4x, which is 7x, plus 3x is 10x. And then negative 19 minus 1, which would give me negative 20, is equal to 180. Plus 20 on both sides. That would give me 10x is equal to 200, making x equal to 20. Okay, because 10 divided by both sides would give us 20. Okay, so that means that the measure of angle A would be 30. The measure of angle B would be 80 minus 19 is 61. And, or 51. No, that's 51. 80 minus 19 is 51. Let's try it. 80 minus 19. That's 70. No, it's 61. My bad. And then the measure of angle C is 3 times 20 is 60 minus 1. I'm like having brain freeze right now. It's 59. Okay, so answer choices are A. AB is the longest side of ABC. Well, let's replace that A with a 30. Let's replace that B with the 61 and replace that C with a 59. Okay, so and let's go ahead and give us our smallest, medium, largest side labels. So the largest side is the one that's across from that 61-degree angle, which is B. The medium side is the one that's directly opposite C, so that's medium. And then the smallest is the one, of course, that's directly opposite A. So AB, side AB is the longest side. Check it out. AB is not the longest side. It's the medium side. Triangle ABC is an isosceles. Nope, it's not. The sides have all different angle measures. I'm sorry. The sides have all different measures, or lengths, rather. And CAC is the longest side of ABC. Yes, I agree with that. I totally agree with that because side AC is opposite angle B, which is 61 degrees. All right. This next one here, the coordinates of endpoints of segment AB are A, -6, -5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. You could use the formula for this. You don't have to graph it. 1, 2, 3, 4, 5. Excuse me. And just gonna refigure that. Almost fell out of my chair. And then B is 1, 2, 3, 4, 0. You want to label that? A and B. Okay, and then you want to connect those segments. I don't have a ruler, but I have my We Should All Be Feminists book right near me. I was reading it today. So I'm going to use that as my ruler. Okay. Alrighty. And so it tells us that point P is on segment AB. We don't know where it is yet. But we want to determine and state the coordinates of point P such that the ratio of point P to AB is 2 to 3. So one way that I showed students to do this, and it's a very easy way that another student, a colleague of yours or a peer of yours did this, is that finding the rise over run is a really good way to do it. Okay, so let's try to figure out, or just look for where, the line intersects the graph. So it looks like if you go up 1 over 2, up 1 over 2, that's your rise over run. Up 1 over 2, up 1 over 2. Okay, so what you'll notice is that you've broken this up into 1, 2, 3, 4, 5 segments. Okay, and if we're looking at a ratio of 2 to 3, we can start from A, and we have to because it's a directed line segment with a distinct starting point, and that starting point being A, and then we count off 2 from point to point. So we have 2 units, right? This is our partition point, P, and then we have 3 units to the left of that partition point. And so that's why P, this partition point, with its coordinates at 1, 2, -2, 1, 2, 3, -2, -3 is the answer. Okay. On to number 11, which I'm just going to review very, very, very quickly. All right, so it says in the diagram below, the measure of angle BDC, right? Let's underline that. BDC, which is right here, BDC is 100 degrees. The measure of angle A is 50. And the measure of angle DBC is 30. Okay, so we're asked to prove why triangle ABC is an isosceles, and it was already circled for you. You're just proving that, okay, with your tick marks and all that other stuff. So if this is 100 and that's 30, that means that this is 50, of course, right? Because 100 plus 30 plus 50 is 180. And then what about what's going on here? Well, we have a linear pair, and so that has to be 80, right? And 80 plus 50 is 130, which means that this has to be 50. All right, so is Triangle ABC Isosceles. ABC. Is it an isosceles triangle? It sure is. Why? Because these two angles are congruent to each other. Because keep in mind, yes, this is more than one triangle going on here. We have one, two, and then the big mama triangle, okay? And looking at the big, and that's going to happen in the bonus situation too. I'm trying to give us the same amount of arc marks. Arc marks indicate congruence, and I want to make them neat, but kind of sloppy. No big deal. All right, so we have the same amount of arc marks here as we have here. And what that means is these two sides are going to be congruent, making this an isosceles triangle. And sorry for the sloppiness. Okay, so we're done with that. And finally, let's attack this monster of a bonus question, which unfortunately not many of us were able to get, but we're going to go over this together and I'm sure it will make sense. And if it doesn't, please see me after school and we can talk further about it. In the diagram below of triangle MNO, angle M and angle O are bisected by segment MS and segment OR, respectively. So segment MS and OR bisect angle M. So we have a pair of congruent angles here because bisect means split into two congruent parts, and this is the bisector. And then angle O is also split into two congruent parts because its bisector is OR. Okay, segments MS and OR intersect at T, and that always means you're going to have some vertical angles happening here. Okay, and so that's important. And then measure of angle N is 40 degrees. So it says here, if the measure of angle TMR is 28 degrees, the measure of angle OTS, well, I'm going to put a question mark here, is what? So using the information they've given us, we know that this is 28 and that's 28, okay? So these two angles are 28 degrees. What else do we know? Well, if I look at this big triangle NOM, right, that's 56 and that's 40. I can figure out what this is. 40 plus 56. How do I know it's 56? 28 plus 28 is 56. I'm looking at the big triangle. And let me get a marker to indicate that. All right, luckily my daughter had her colored pencils out. So I'm looking at the big, the whole triangle here. And then I took this, right, this angle, and I'm adding them up, and I'm going to subtract that from 180. So 180 minus 96 is 84. So that means this whole thing is 84. But because it's being bisected, each piece is half of 84. Okay, just like this was 56, but it was bisected, so we got 28 and 28. So 84 divided by 2 is 42. So that means this piece here is 42 and that's 42. So that means angle SOT is 42 and MOT is 42. Okay? And so that's supposed to look like a 42. Let me fix it. So what other information can I use here to figure this out? Well, I feel like I have enough information to determine another missing piece. So I know that that's 42, right? So this angle right here is 42. If I could figure out what this one is, I could figure out what this is. So now I'm going to look at this particular triangle here, because this is another triangle, and I'm using pink for this, and so I'm going to shade it in to indicate that I'm using this triangle here to figure out the measure of this missing piece. Okay, so 28 plus 84, right? Let's add those up. 28 plus 84, right? Triangle MOS is what I'm looking at now. Would give me 112. So 180 minus 112 would give me 17. And there's many ways that you could do this. So some people are like, Miss Clark, you're doing a lot of work here. That's fine. You can do this whatever way you wish. This is how I did it. Okay, so this angle here is 68 degrees, is what I figured out. Okay, because I took this whole triangle, right, 28 degrees, 84 degrees, and then I used the triangle sum theorem to figure out this. So now I can go back to this small triangle here, and I'm going to color that one in too. I'm just going to overlap that in green. It's almost like a puzzle, if you like puzzles. All right, so that's 68, that's 42. Again, I'm going to use triangle sum theorem. 42 plus 68 is 110. 110. So that means OTS, this angle right here, is 70 degrees. Let me fix that. 70 degrees, right? Because 180 minus 110 is 170. 180 minus 110 is 170, right? So 70 plus 42 plus 68 would give us 180. So your answer should have been D. See you tomorrow.